welcome to our channel. Today, we're diving into a fascinating topic that has captivated the imaginations of scientists, science fiction writers, and frankly, anyone who's ever wished they could undo a mistake. Can we really rewind time with a wormhole? We're talking about the mind-bending world of theoretical physics, where wormholes, these theoretical tunnels through space-time, might just hold the key to unlocking the secrets of time travel. Let's explore the theories, evidence, and challenges surrounding this concept, and see if we can separate science fiction from scientific possibility.
Imagine a piece of paper, right? Now fold it in half. You see those 2 points touching? That's kind of how we visualize a wormhole, except instead of a piece of paper, it's the very fabric of space-time itself that's folding. These theoretical shortcuts through space-time, predicted by Einstein's general theory of relativity, could potentially connect two vastly distant points in the universe, or even different points in time. Think of it like taking a cosmic shortcut, instead of traveling the long way around. The truth is, we haven't observed a wormhole directly. They remain purely theoretical constructs, mathematical possibilities woven into the complex tapestry of Einstein's equations. The very fact that wormholes emerge from our best understanding of gravity makes them a compelling subject for physicists to study.
Okay, so we've got these theoretical tunnels through space-time, these wormholes, but how do they relate to time travel? Well, this is where things get really interesting. Imagine a wormhole connecting 2 points in space-time. Now imagine one end of that wormhole is moving at a significant fraction of the speed of light. According to Einstein's theory of special relativity, time slows down for objects traveling at high speeds relative to a stationary observer. So if one end of the wormhole is moving near the speed of light, time would pass differently at that end compared to the other end, which is stationary. This would create a time difference between the two ends of the wormhole.
Now you might be thinking, Neil, this all sounds a bit far-fetched, and you wouldn't be alone. But here's the thing. Some of the brightest minds in physics have grappled with the concept of wormholes and their potential for time travel. Physicists like Kip Thorne, whose work inspired the movie Interstellar, and even the legendary Stephen Hawking, have explored the theoretical possibilities of using wormholes for time travel. Thorne, for example, proposed a scenario where a wormhole could be used to create a closed time-like curve, essentially a loop in space-time that would allow for travel through time. The idea is that if you could somehow manipulate the entrances and exits of a wormhole, linking two different temporal locations, you could potentially create a loop that would allow you to travel back in time and meet your younger self.
Here's the thing about wormholes. They're not exactly the most stable structures in the universe. In fact, according to our current understanding of physics, they would collapse faster than you can say quantum entanglement. To keep a wormhole open and traversable, you would need something truly extraordinary, something called exotic matter. Now, this isn't your everyday garden variety matter. Exotic matter is hypothetical stuff with negative energy density. This negative energy density would create a sort of anti-gravitational effect, pushing the walls of the wormhole outward and preventing it from collapsing in on itself. The problem is, we've never actually observed exotic matter. It's purely theoretical at this point, and even if it does exist, creating and harnessing enough of it to hold open a wormhole would require technology far beyond anything we can currently imagine.
Now, even if we could somehow overcome the technological hurdles of creating and stabilizing a wormhole, we'd still face a whole other set of challenges. Challenges that strike at the very heart of what we understand about causality and the nature of time itself. Let's talk about the elephant in the room, or rather, the paradox in the wormhole, the grandfather paradox. It's a classic thought experiment in time travel that goes something like this. Imagine you travel back in time and accidentally kill your grandfather before your father is born. Now, if your grandfather is dead, your father couldn't have been born, and neither could you. But if you were never born, you couldn't have traveled back in time to kill your grandfather in the first place. It's a logical contradiction, a temporal head-scratcher that has plagued philosophers and physicists for decades. One theory suggests that time travel might be possible, but only within a closed loop. In this model, you wouldn't be able to change the past, only fulfill it. Another theory proposes the existence of parallel universes, where traveling back in time would actually transport you to a parallel universe, one where you could interact with the past without affecting your own timeline.
Let's say, for argument's sake, We figure out this whole exotic matter thing. We find a way to bottle it, synthesize it, maybe even order it in bulk online. Even then, the stability of a wormhole remains a major point of contention. See, it's not enough to just prop open a wormhole with exotic matter. You need to make sure it stays open long enough for you to actually travel through it. Think of it like holding a soap bubble between your hands. You need just the right touch, the perfect balance of pressure to keep it from popping. Some physicists believe that quantum effects, the strange and counterintuitive laws that govern the subatomic world, might hold the key to stabilizing wormholes. Perhaps quantum fluctuations in the fabric of space-time could be harnessed to create a sort of scaffolding, a framework to reinforce the wormhole's structure. So far, we've been talking about wormholes as if they're these massive cosmic structures, shortcuts between galaxies or even different points in time. But what if wormholes aren't these grand interstellar highways, but rather tiny subatomic tunnels, flickering in and out of existence at the quantum level? There are theories suggesting that microscopic wormholes might be popping up all around us, right here, right now. These quantum wormholes, as they're called, would be far too small for a human to travel through. But they could have profound implications for our understanding of the universe. Some physicists believe that these quantum wormholes might be the key to unifying general relativity, our best theory of gravity, with quantum mechanics, our best theory of the subatomic world. Others speculate that they could be responsible for the strange and spooky phenomenon of quantum entanglement, where two particles become linked, even across vast distances.
Quantum mechanics, that wonderfully bizarre realm where particles can be in multiple places at once, and cats can be both dead and alive, might just hold the key to unlocking the secrets of wormholes. See, there's this intriguing connection between wormholes and a phenomenon called quantum entanglement. Imagine two particles linked in such a way that they share the same fate, no matter how far apart they are. You measure the spin of one particle, and instantly, you know the spin of the other particle, even if it's light years away. It's like they're connected by an invisible thread, a cosmic umbilical cord. Now, some physicists believe that this invisible thread, this spooky action at a distance, might be a wormhole.
Now, let's address the question that's been on everyone's mind. Could humans ever travel through a wormhole? And the answer, as with most things in theoretical physics, is a resounding maybe. Right now, we simply don't have the technology to create, stabilize, or even find a naturally occurring wormhole, let alone send a human through one. It would be like trying to build a spaceship out of wishes and dreams. But that doesn't mean it's impossible. If we continue to unravel the mysteries of the universe, if we can unlock the secrets of exotic matter and quantum gravity, then perhaps, just perhaps, human travel through wormholes might one day be possible. Imagine a future where we could step through a wormhole and emerge on the other side of the galaxy, exploring new worlds and encountering new civilizations. Imagine the possibilities for scientific discovery, for cultural exchange, for the advancement of our species.
Let's say, for a moment, that we do crack the code of wormhole travel. We figure out the exotic matter, stabilize those quantum fluctuations, and even build a spaceship capable of withstanding the journey. Are we home free? Not quite. Because even if we can travel through time, the question remains, should we? The ethical and philosophical implications of time travel are perhaps even more mind-boggling than the science itself. Think about it. The ability to change the past, to undo mistakes, to right wrongs. It's a tempting proposition, but one fraught with danger.
Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Let us know in the comments what you think about the possibility of rewinding time with a wormhole. Is it a scientific possibility, a philosophical conundrum, or just a fun thought experiment? Until next time, keep exploring the mysteries of the universe.